Hi everyone, welcome to the artifact-based rendering tutorial. We're going to hope to show you today how you can create 3D VR visualizations by hand. So translating work with traditional artistic media, clay, paper, paint, into a form where they become data-driven, interactive, immersive visualizations. My name is Dan Keefe. I'm a professor at the University of Minnesota, and I'm presenting this work together today with the Sculpting Viz Collaborative. This is a group of artists, computer scientists, and domain scientists who've been working together on this project for several years now. The roadmap for the tutorial today is as follows. I'll begin by talking just a bit more about what is it we actually even mean when we say VR visualization by hand, and then we've divided the remainder of the day into two parts. So first part, we'll learn more about the software and the processes, even some of the design theory that underlies this work. And then in part two, we'll actually use the tools. So we're going to run synchronous sessions in part two where we'll actually connect up to a server-based design architecture we've built to do collaborative VR visualization design. We hope you'll stick with us the whole time. Much of this work began motivated by this question. Would it even be possible? Could we design data-driven 3D visualizations in the same way creative visual thinkers like artists work now in their studios, the way they work with traditional tools like clay, paint, ink, and paper? And you might ask, well, why would you want to do that anyway? And I wanted to give you just three reasons today. One is broadening participation in visualization. In particular, 3D visualization, where often to be really creative in that space, it can require graduate level 3D programming skill. So we think if we can open up to a broader group of visual designers, that this might enable us to discover new solutions to visualization problems that we haven't even thought of before. I guess a more specific example of that, and the second reason, is to expand the visual vocabulary we use. If you take a walk outside in nature, or you walk through a museum, or even an artist's studio, the richness of the visual language that surrounds us really pops out. And if you think about the aesthetic of the data visualizations that we typically see, especially for scientific data, it's very sterile. It doesn't have that same richness. So we wonder if we can actually pull from nature, from the physical world, then we might be able to get a much richer visual vocabulary that actually leads to us being able to even encode more data. A third reason is to make our visualizations more approachable. You know, we're in a time now where science itself is often under attack. How do we bring a more human relatable, engaging natural aesthetic to our visualizations? What if even the aesthetic of our data visualizations in science showed evidence of the human hand behind it? You know, we think this might actually end up making science itself much more approachable. So with this motivation in mind, we've been working over the last several years to create this framework we call artifact-based rendering. And the big engine behind this, in terms of the computer graphics, was presented in last year's VIS paper session. And then we've continued to build on this. Oh, I should say also last year the design theory was presented in the arts program. This year we're continuing to build on this, and you can see we've evolved to the web-based interface we'll use in part two of the session today. We've been interested in how we might evaluate the visualizations that come out of this methodology in terms of their capacity for human engagement. And in the Believe workshop, we'll present some humanities style evaluation techniques for that. And then there's also a poster connected to our team this year where we discuss how you can create auto-generated legends using these artifacts. So we hope you'll join us for these things, just some pointers to where this all comes from. What I want to do now is quickly go over the stages of this process we've developed. And step one, as I've alluded to, really comes down to getting in the studio, working with traditional tools, paint, clay, carving, thumb printing. We've looked at doing rubbings of natural textures, prints, taking photographs of friends' paintings, going out and photographing even just color that appears in nature. And all of these serve to create the visual language that is like the starting point for the data visualization. So we call those things artifacts, as in the physical artifacts that come up. And I should mention here also that as we're collecting these, it's not just like randomly go out and pick some flowers. Okay, we're actually thinking very deliberately about encodings. And one way we've helped artists to sort of have that mindset as they're working and developing these is to think about a structure like this. Thinking about encoding points, lines, surfaces, and color, and thinking about how those encodings might change based on whether you want to show a scalar progression, as in a magnitude channel, or sort of a categorical distinction. And artists get this. This is not difficult to understand from a visual standpoint. So this can often sort of guide the curation of artifacts. Once we source these from the physical world, the next step is to digitize them. And we've looked at a number of different processes for that, but we rely a lot on 3D scanning, especially for clay forms that might end up serving as glyphs in a final data visualization. We've used photography quite a lot. And there's a number of really neat things that might show up in the future, even lighting dependent appearance capture. I mean, really getting the reflectance, for example, of these surfaces. And then the next step is to translate those artifacts into a form that can be used directly by the computer graphics rendering engine. And this process can take different forms, but in a nutshell, we've created a series of web-based applets that allow you to upload the digitized artifacts and then do any tweaking that is necessary. Sometimes that's downsampling. Sometimes it's like treating the image as a sample to then generate a longer infinite line texture like you see in this applet. We've also done work that allows you to, for example, indicate a forward direction for a glyph. So you're sort of priming these artifacts to be used in the computer graphics rendering engine. Then the next step is to use these now graphics-ready artifacts and connect them to data. And there's a special user interface we've created to do this. It's actually the focus of a VIS app paper this year, because it's quite interesting from an artistic standpoint. It actually builds off the metaphor of printmaking. The way prints are put together with multiple plates and can be inked with different colors and so forth. So this user interface draws upon a printmaking metaphor actually to really quite clearly translate this problem of how do you map data onto visuals in a user interface form. You'll get to actually try that in part 2 of the tutorial today, so we're looking forward to showing this off to you. But this is the interface that creates that mapping from data variables to the visual artifacts. Okay, once that mapping is made, you then get your 3D visualization. we're just, as we get more and more into this, looking at the impact of the work, you can see just from some of the visuals, the aesthetic that's created is often quite different. But we want to understand like what's the benefit, if at all. And I want to point out one benefit we're really quite sure about at this point. It's basically the ability to rapidly iterate and explore new spaces in the visual, in terms of the visual language for data visualization. So if your goal is creative design, this framework works really well, and we're getting results like artists working with this are able to explore 100 different visual designs in a day. And when we compare it to more traditional tools, we find this is just like a totally different ballpark in terms of the amount of rapid iteration and exploration of the design space you can do. Okay, of course that also has pitfalls. Maybe you're going in the wrong direction. But artists and designers are used to that, and they're happy to throw away 90% of the results and get to that 10% that are really spot on. So rapid exploration of design alternatives, really something really special with this. The final results can be explored in VR. They can be just shown on a 3D desktop as well. And some of the interesting comments we've gotten, for example, Phil Wolfram, one of our collaborators studying this data in the Gulf of Mexico, just gave us this quote, which I just absolutely love. Speaking of the visualizations, he said, "They look more like biology than they look like plastic. They could be real, produced by nature." And he says, "I think people are going to underestimate that. At first I'm perturbed. These don't look like plastic. And then I realized this is not a problem, but a major benefit." And so we think this is part of what's so interesting here, is the potential for the visual language to even connect with sort of a human element. This is nature. This feels right. And it's not sterile. It's just embracing this is natural. And that actually is quite different, but maybe it's time for some of that in our scientific visualization. So we invite you to try. Just to reiterate our schedule today, so the next session that's coming up is learning a bit more about these processes, and we'll start off with a demonstration of the user interface that I showed you just a quick picture of before. So you can see that stage of mapping data onto the visual artifacts. By the way, the artifacts themselves we store in an online library, which is open for anyone to use. And so in that demonstration, we'll be pulling examples from the library. So please join us for the next set of videos, and then we look forward to seeing you in person for the Use It session, where we really give all the software a good try. So, by the way, this work is supported by the National Science Foundation, and we're really thankful to them, as well as the Domain Science collaborators who've provided some very high-end data sets, latest high-performance simulation involved in those, and we'll show you some of those today. You'll actually get to work with some of those data sets as well. So thank you so much. We'll look forward to seeing you throughout the day.